Yeah, hello everyone. So I'm going to start the second part of this paper, October-November 2021, paper 2. First 11 questions I already solved in the previous video. And in this video, we are going to continue from question number 11. So, sorry, question 11 we finished. So question 12 we will be starting with. The table shows the first 5 terms of sequences A, B, and C. So 3 sequences are mentioned here. We are asked to complete the table to show the nth term of each sequence. So first sequence is A, 8, 3, -2, -7, -12. So it could be a linear sequence. We have to check whether it's a linear sequence or not by finding the difference between the terms. So 3 minus 8, we know that the difference is second term minus first term. 3 minus 8 is -5. Difference between these two terms is -5. -2 minus 3 is also -5. -7 minus 2 is also -5. So it means the common difference is 5. So nth term will be -5n plus, and always once we identify the common difference, then we can write the nth term for a linear sequence. The common difference times n plus or minus the 0th term. That means the term that should come before the first term. It means we are going to right, so we are subtracting 5. If we are going to left, we are adding 5. So -12 plus 5 is -7 and so on. So 8 plus 5 is 13, so it should be 13 here. And to confirm that it's right, we can take if n is 1. So we should get this answer 8. So if n is 1, so 13 minus 5 is 8. If n is, let's say, 3 or 4, so 5 4s are 20. -20 plus 13 is -7. Yeah, so it means it works. Then we have a second sequence, 2, 3 over 2, 4 over 3, 5 over 4, 6 over 5. So what we see here, if we just leave at this first stage, the first term, and we compare the rest of the terms, so 3 over 2, 4 over 3, 5 over 4, 6 over 5. So in each fraction, in each term, we have a fraction. The numerator is 1 more than the denominator. 2, 3, 3, 4, 4, 5, 5, 6. It means this should be 1, 2. We can write 2 as 2 over 1, 1, 2. So denominators are 1, 2, 3, 4, 5. Numerators are 1 more than the denominator. So if we want to write the next term, it should be 6 and 7, 7 over 6. So it means if we want to write the nth term, where n is any position, so first position, we have denominator 1. Second position, we have denominator 2. So position and the denominator are the same. So if we want to write the nth position, so denominator should be n. And the numerator is 1 more than the denominator, so n and n plus 1. So this is the nth term of this sequence. And the third sequence is 1 over 2, 1, 2, 4, 8. Again, if we first stage, we ignore first term, then we get 1, 2, 4, 8. And what we see here, it is the sequence is increasing rapidly, like 1, then 2, then 4, then 8. So we can say we are multiplying by 2. Or otherwise, we can also consider that these are the powers of 2. So like this is 2 raised to the power 1, I mean 0. And this is 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3. And this can be written as 2 raised to the power -1. Because 1 over 2 is same as bringing 2 up, becomes 2 raised to the power -1. So now we need to link the position and the powers. We see that the base is same, 2, 2, 2 in every term. So 2 is not changing, only the power is changing. So what is the relation between the power and the position? So first position is the first term. The power is -1. Second position, power is 0. So third position, power is 1. So if it means from position, if we take 2 out, 3 minus 2 is 1. 2 minus 2 is 0. 1 minus 2 is -1. 5 minus 2 is 3. So whatever the position, to get the power, we subtract 2 from the position. So it means for the nth term, we should say the position number is n, so n minus 2. So we have mentioned all the nth terms of all the sequences. And this carries 5 marks. Okay, write 243 times 27 raised to the power 2n as a single power of 3 in terms of n. So as a single power, that means there should not be multiple numbers and we should have only 3 raised to the power something. No other power should be there. So we just need to rewrite these numbers. You can just try on your calculator that this number is 243 is divisible by 3. So if we want to know exactly, so if we divide 243 by 3, we get 81. And then 81 again, if we divide by 3, we get 27. So all these numbers are divisible by 81. You can say you are writing in factorized form. 243 can be written as the product of all threes. 3, 3, 3, 3, 3. How many 3's are there? 3 raised to the power 5. So 243 can be written as 3 raised to the power 5. And 27, I made a mistake somewhere. This should be 27. Here. And then this should be 9. And then we get 5 3's, not 6 3's. So that's why it should be 3 raised to the power 5. Similarly, 27 can also be written as 3 times 3 times 3. That is 3 raised to the power 3. This is 27 raised to the power 2n. So we will get rid of this bracket, and by applying the indices rule, the power inside the bracket and power outside the bracket needs to be multiplied. So we can write this as 3 raised to the power 5 as it is times 3 raised to the power 3 times 2, 6n. And then finally, by applying the rule, when we are multiplying two numbers with same bases, we add the powers, which should be 3 raised to the power 5 plus 6n, or 6n plus 5. So we have converted this given number into a single power of 3 in terms of n. We can write 3 raised to the power 5 plus 6n as the answer of this part. Then k is equals to 2 times 3 squared times p cubed, where p is a prime number greater than 3. Write 6 squared as a product of prime factors in terms of p. So we are given that k is this. We have to write 6k squared as a product of prime factors in terms of p. So we know that k is this. 6k squared, that means we have to multiply k by k to make it k squared and then multiply by 6. So k multiplied by 6k will give us 6k squared. So the left side we can say k 6k squared, and the right side we have to write the answer as a product of prime factors in terms of p. So we know that k is this. So we can replace k by this k here, and again we have so when we multiply, we bring the same bases together, 2 times 2, which can be written as 2 raised to the power 2. 2 times 2 is 2 raised to the power 2 times 3 squared times 3 squared. So power will be added. Power 2 will become power 4. P3 and P3, so will become P raised to the power 6. And still there is a 6 here that need to be taken here. And as we need the product of prime factors, so any factor that we are writing should be a prime number, not a composite number. So 6 can be written as 2 times 3 as also. So we can split 6 as 2 times 3, and the rest of the thing we have simplified. So another 2 has come here, so another power of 2 will be increasing by 1, and another power of 3 will also increase by 1. So it will become 2 raised to the power 2 plus 1, which is 3, and 3 raised to the power 4 plus 1, which is 5, times p raised to the power 6. So we have expressed 6k squared as the product of prime factors in terms of p. This should be our answer. 2 raised to the power 3, 3 raised to the power 5, p raised to the power 6. Number 14, circle theorems. PQR points on a circle. ST is a tangent. Write down the value of x. Give a reason for your answer. Here is x, x is here. So you have learned the circle theorems. So we should know that there is a theorem that links this angle. This angle is angle between a tangent and a chord. ST is a tangent and QR is a chord at the point of contact. This is alternate segment theorem, which says that angle at the point of contact between the tangent and the chord is the angle subtended by the chord in the alternate segment. So alternate segment angle is 755. So x is equals to 55 degrees. Reason could be written as alternate segment theorem. We don't need to write the whole theorem. We can just refer to this theorem, that this is the theorem we are applying. So angle between tangent and the chord is equals to the angle subtended by the chord and the alternate segment. If you want to write the complete statement, you can write it. Otherwise, this reference is enough. Another tangent from the point S touches the circle at B, which is not shown. Give a geometrical reason why triangle SVR is isosceles. Another tangent from the point S touches the circle at B. So from point S, if we take another tangent, so roughly we can take it like this. It will meet the circle somewhere, not necessarily at Q, but it may be anywhere. And we are told that it will meet at V. We can label that point. Suppose it is meeting here. So there's a theorem which tells us that from one point outside the circle, two tangents can be drawn toward the circle, and the length of the tangents will be same. and hence the triangle QRS is an isosceles triangle. So you can refer to this theorem, or you can just write a brief statements. Tangents drawn from outside the circle, tangents drawn from a point outside the circle are equal in length. So when they are equal, then definitely this will become an isosceles triangle. The sides are equal. Question 15. A is a point, this, B is this point. Find the equation of the line that passes through A and B in the form y equals mx plus c. So we know that equation of a line can be found by writing it in this form, which is m stands for gradient. So we need to find the gradient from 2 points. So gradient from 2 points can be found by using the formula y2 minus y1. M is the gradient. So this is our first point. We can call x1, y1, x2, y2. So y2 minus y1, 31 minus 16 over x2 minus x1, 8 minus 3. It's 15 over 5, 3. So gradient is 3. So we can write the equation y equals mx, which is 3x plus c. To find the value of c, we can substitute the value of x and y from any of these points. So let's choose this point. X is 3 and y is 16. So y is 16, x is 3. So from here we can get the value of c. So 3 3s are 9. So we can say 16 minus 9 is c, because this 9 will go to the other side, will become negative 9. So c is equals to 7. So finally, we can write the equation y equals 3x plus 7. The line CD has equation y equals 0.5x minus 11. Find the gradient of a line that is perpendicular to the line CD. So if we compare this equation of line CD, we know that equation of line is y equals mx plus c. So mx plus c. So m is 0.1. So gradient of line CD is 0.1. So we can say gradient m of CD is 0.5 from this equation. The gradient of the line that is perpendicular to CD. So here we need to know a basic rule that when two lines are perpendicular to each other, then the product of their gradient is -1. Or if we know the gradient of any one of the line, the other line will have the gradient, the opposite reciprocal of the first line. So we can write 0.5 also as 1/2, so that we can easily take the reciprocal. So the line which is perpendicular to CD will have the gradient opposite to this. Opposite to mean the sign to change. It's positive half, so it becomes negative half, and reciprocal. So reciprocal means 1/2 will become 2/1, and the negative opposite reciprocal. So gradient will be -2/1 or just -2. Because product of two gradients will be always -1 when two lines are perpendicular. So M1 is equals to opposite of M2 and reciprocal of M2. Number 16, Sachin picks a number at random from the first three multiples of 3. He then picks a number at random from the first three prime numbers. He adds the two numbers to find the score. Complete the table. So multiples of 3. First multiples of 3 are here. It should be 6. Multiples of 3 are 3, 6, 9. And then he picks a number from the first three prime numbers. So first three prime numbers are, first prime number is 2, then 3, and then 5. 2, 3, and 5 are the prime numbers. Then what he does do after that, he add the two numbers. So 3 and 2 when he got, so he added them to 5. So 6 and 2 he will get 8. 9 and 2 he will add, he get 11. So like that we can complete the table. So 6 plus 3, 9 plus 3, 3 plus 5, 6 plus 5, 9 plus 5. So we have completed this table. Given that the score is even, find the probability that one of the numbers he picks is 9. So it's given that, so it means it's conditional probability. So a conditional probability means we are already having some information prior to finding the probability. What conditional information is there that we need to analyze here carefully? That the score that he got is even. So if we look at the table, what scores are even? And the scores are shown under these 9 boxes. So which scores are even? This is even, this is even, this is even, and these two are even. So it means he is going to pick a number from these numbers only. So find the probability that one of the numbers he picks is 9. So in how many outcomes one of the numbers, because he got these numbers by adding two numbers. So first of all, what is our sample space? What is total possibility, total possible outcomes in this case? 1, 2, 3, 4, 5. So there are 5 outcomes where we have even number. That is the possible sample space. Sample space is the set of all possible outcomes. So score is even means we can only get the even score. So it means the rest of the numbers are not possible. Now, among these 5 results, we have to see in how many ways he picks one of the numbers he picks is 9. So 9 only appears as multiple of 3. So we can get 12 when he chooses 9, or when he chooses, he can get 12 or 14, both with 9. So when he gets 9 on as a multiple of 3, then he can have two sums, 12 and 14. So there are 2 ways favoring his outcome out of 5 ways. So probability in this case will be 2 out of 5. Because there are 5 ways he can choose. Altogether, there are 5 ways. The result can be an even number. And out of those 5, the number he has chosen can be a 9. And there are 2 occasions that happen, like when the score is 12, there could be a 9, or when the score is 14, there will be a 9. So there are 2 ways to get a 9 out of 5 ways according to this condition. Okay, so the next part. Solve this equation. So we are given the product of the two numbers equal to 0. It means either the first number is 0 or second bracket is 0. So from here we get x equals 3 over 5 And from here we get x equals minus 7/2. So 3/5 or 0.6 and minus 7/2 or negative 3.5. Both answers can be written in decimal or in a fraction. Solve the simultaneous equation. You must show all your working, so you can't just directly use calculator to write the answers. You have to show the working in order to score the marks. So we have to solve. One is quadratic equation, one is linear equation. So we have to solve by substitution. So this value of y and this value of y will equate. So we get x squared minus 9x plus 21 is equals to 2x minus 3. So by substitution method, we equate the y values for both. And then we rearrange this equation so that we can further simplify and work out the answer. So bringing both of these terms to the left, x squared minus 9x and 9x and 2x are the like terms, and 21 and 3 are the like terms. So it simplifies to minus 9 minus 2 minus 11. And 21 plus 3 is 24. And we can try to factorize it. So factors of 24, which we multiply, we should get 24. And when we add, we get negative 3. So negative 8 times negative 3 will give us positive 24. And when we add them, we get negative 11. So we can directly write the two factors x minus 8 and x minus 3 equal to 0, which will give us x equals 8, because x minus 8 equal to 0 will give us x equals 8 and x equals 3. So we have to find the value of y also. We have found the values of x. So we got two values of x. For each value of x, value of y to be found. So y equals 2x minus 3. 2x minus 3, that means 16 minus 3, 13. And here y equals 2x minus 3. So 6 minus 3 is 3. So two pairs of values we get, 8, 13 and 3, 3. So x is 8 and 3. Y is 13 and 3. So we have to write this. When x is 8, we got the value of 13. We have to write this in pairs, proper pairs. So when x is 8, we got y 13. We can't attach this y with this. We got this value when x was 8. So that pair we have to make. And when x is 3, y is also 3. In these Venn diagrams, shade the given regions. A complement union B complement. So for the shading, what we can do is, first of all, we can identify all different areas which are there on our diagram. So usually I label them like this area which belongs to none of the sets A and B, that means outside of A and B, that let's call this 1. And this part of the diagram 2, 3, and 4. You can label in any way, writing A, B, C, D, 1, 2, 3, or any other way. So A complement means which parts are belonging to A complement. A complement means out of A, not A. A is this whole circle. That is 2 and 3 makes A. So outside of A means other than 2 and 3, whatever is there, that is outside of A. So we can say that A complement is 1 and 4. Similarly, we'll see what is B complement. B complement means out of B, and B is this whole circle, that is 3 and 4 forms B. So other than B, out of B is 1 and 2. So when we are asked to shade and we have a union, so union means all of these to be shaded. And 1 is appearing twice. Anyhow, it's just one area, so we don't need to consider this twice. So 1, 2, and 4 that we are combining here to make it the whole thing. Union means to combine them. So these areas to be shaded. That means 3 is not here. 3 should not be shaded. The rest of the part we should shade to get the answer for this part. So that means we should shade not 3, other than 3, everything to be shaded. Only this part will be left unshaded. And if you are writing these numbers with pencil, that's a good idea. You can erase at the end after identifying the area to be shaded. So you can erase it so that only the actual data left. Okay. Similarly, what techniques we did here, we can do the same way here. So we have two parts. C union D is one part and E complement is the other part. And in between we have intersection. Intersection means the common. Union mean all, not common only. So C union D, that means all the parts belonging to C and all the parts belonging to D to be taken together. So C union D, it means this, all the parts in C and D. These are all the parts in C and D. Though this part is belonging to E, but we are seeing that it is part of D. This part is belonging to C, that's why we are taking it. And then what parts are belonging to E complement, that means out of E. So E is this whole circle. Anything outside of E that we have to consider. So let me cross them out of E, and one is this area. This is the outside area. This is outside area. This is outside area. So these are inside areas. So intersection means the common between this and this. So where we have ticks and crosses together, that is the common area. Like here we have a tick and a cross, that means it belongs to C union D as well as it belongs to E complement. So intersection means to take common. So the common areas now we are going to shade. So one is this. This is the other one. This is the one. And that's it. So these three areas to be shaded. And that will be your answer. Question 20, f of x is this, g of x is this, and h of this. F of 6. So first of all, we have to find what is f of 6. In f function, we substitute 6 here. On the other side also, we substitute 6 in place of x. So it is 2 raised to the power. X minus 3 means 6 minus 3, that is 2 raised to the power 3, which is 8. Then another f means, again, now we have to find f of x. So f of 6. And f of 6 we found is 8. That means we have to find what is f of 8 now. So in f function, we substitute 8 in place of x. So 2 raised to the power 8 minus 3. 2 raised to the power 5, which is 32. Find G inverse G x plus 21. So we just need to remember when two function, one is inverse of other, like f inverse cancels out each other if we have anything inside the bracket like this. So answer will be that number here. So f inverse x is x. G inverse G3 is 3. G and G inverse cancels out, only 3 will be left. So likewise, G inverse and G can be cancelled out, and the answer is x plus 21. Find x when f of x is equals to h of at 84. So let's see what is h of 84. H of 84 in h function, in place of x we replace 84. So h function is 5 over x minus 4, that means 84 minus 4. So 5 over 80, 1 over 16. So we are told that find x when f of x is equal to this. So f of x is equal to this means, what is f of x? 2 raised to the power x minus 3 is equals to h of 84, which is 1 over 16. Now we have learned this is x is in power, so it is an exponential equation. To find the value of x, because it's in power, both sides we have to write with the same base. That means 2 raised to the power something. Here also we have to write 2 raised to the power something. So we know that 16 can be written as 2 raised to the power 4. 16 is 2 raised to the power 4. And we have to write it without fractions. So we can take it up. We can say it is 2 raised to the power negative 4. So 2 raised to the power x minus 3 is equals to 2 raised to the power negative 4. So bases are same. It means the exponent should also be same. This we can conclude that x minus 3 is negative 4 and x equals negative 4 plus 3 negative 1. So answer is negative 1. Okay, the last part, expand and simplify. So it's a square here multiplied by 2x plus 5. So we can expand the square, and I can just quickly tell you a technique to find the square of any numbers quickly. A plus b square is square the first number and multiply these three numbers, the power and the two numbers here. 2 times a times b, 2ab. And whatever the sign comes along these numbers, that sign will right. So if all are positive, it will be positive 2 times ab. And then square the second number, b squared. So these two numbers will be always positive, and this number may be negative if one of the numbers is negative. Otherwise, first and the last number will be always positive. So applying this quick method here, we can expand the square. So first number square, which is x squared. Then we multiply 2 with negative 3 with x. So if we multiply these two, negative 3 times x is negative 3x, and then times it by 2, so negative 6x. And the square of second last number, it is positive anyway. So 3 squared is 9. So we have expanded this squared, and then should be times by 2x plus 5. And then to time this, we have to multiply each term. Like if I multiply this one, each term of this to be multiplied with all the terms, and then multiply 5 with all the terms of second term. If I start from here, x squared will be multiplied here, x squared will be multiplied here then. Then second term multiplied here, second term multiply here, third term multiply here, third term multiply here. So we will get here x squared times 2x cubed. Then minus 6x times, okay, let me first multiply x squared with both of the terms. So x squared times 2x is this. X squared times 5 is 5x squared. So I have multiplied x squared with both of the terms. Now I repeat the same thing for the second term. Minus 6x times 2x minus 12x squared minus 6x times 5 minus 30x. And then 9 multiplied by 2, 18x, 9 multiplied by 5, 45. Now we just have to simplify the like terms. X cubed is a single term, no x cubed other than this, so it will stay as it is. 5 minus 12, both are x squared, so minus 7 x squared. 30, negative 30 and plus 18, both are in x, so it will become negative 12x and positive 45. So that's our answer in this form. Okay, question number 22. 7 sine x plus 2 equal to 0. Solve this equation. So we have to make sine x the subject first. So taking 2 to the other side, we get 7 sine x equals negative 2. Sine x equals negative 2 over 7. And then to find the values of x actually, x will be equals to sine inverse 2 over 7. X to be found, so sine to be taken, you can say that sine to be taken to the other side. So it will become sine inverse, and we have to work out the value of sine inverse, negative 2 over 7. So we have got negative 16.601. So I can write 60 degrees. Now, regarding the sine functions, when we are solving questions on trigonometric equations, so we should know that what is the graph of sine function. I just quickly sketch the graph of sine function here. When x is 0 here, and it continues to negative infinity, repeating like this, itself like this, and it goes to the right also like this. So from 0 to 360, it completes one cycle. First it goes up, then comes down, further down, then goes up. So maximum value is 1, minimum value is -1. So between 0 to 360 degree, if we take any one particular point, like these are the angles 0 to 360 degrees. So if I take any angle, for example, this angle, this is 90 here, this is 180. So this angle is between 90 and 180, and sine of this angle is the value here on y-axis. This is the y value. That means sine of, let's say it is 120, sine 190, sine 120 is the number same like what is here. And this value is not for this point only, this also has the same value at this point. That means this x value also has the same y value. It means if this is 120, then at this point, the value of x, whatever the value of x is, it will have the same y value. So what is that value here? We know that from this point to this point, it is 180. It is half of the total cycle. 180, then another 180. So it's, if it is 120 and this is 180, so in between we have a gap of 60. This is 60, then this will also be 60. This is because the graph of a sine is symmetric. Graph of a cosine and sine both are symmetric. So through symmetry, If we see this part 60, then this part will also be 60. So it means sine 60 and sine 120 will have same answers. So likewise, any two values are for any particular angle for sine, we always have two values except these points. Two values in one cycle. So this here we have 2 points for one particular value of y. So we got some value of x, which is negative 16. Negative 16 is somewhere here, suppose. And when x, we want to find the value of this negative 16, we are getting negative 2 over 7. Sine 16.6 is negative 2 over 7. But we are asked to give the answer between 0 to 360. X should be 0 to 360. So if we take a horizontal line, so if this angle is negative 16, then this part is also 16. The size of this angle is 16. Negative is because it is on negative side of y-axis. So this is also 16. So this 16 comes from 180 and onwards. So 180 plus 16 is our first answer. And then we have another answer that comes here. So again, the answer in range will be 180 plus 16. So the second part will be if 360 is somewhere here. So it is not at 360, it is 16 left. It has to be come back 16, then it will come here. Okay, I think I did not draw it properly. That's why there's a confusion here. It's a tiny graph. This is one cycle, and it continues to the other side. It will be going like this up to infinity. So we got negative x, negative 16.6. Negative 16.6 is somewhere here. So as I told, due to the symmetry, whatever the y value here is 2 over 7, negative 2 over 7, that is the y value. So the same y value is everywhere on this line, here as well as here. So the y value is the same, the x values are of same distance from this point. This is 16. So this should also be 16. This should also be 16. I did not draw this accurately, but still, due to symmetry of the graph, we can say this is 16, not exactly 16, 16.6. So we can add or subtract accordingly to get the final answer. So we know that from 0 to this point is 360 degrees. And half of this is 180. This is 180, this is 180, total is 360. So from 180, 16 more, we have to go 16.6. So that's why I wrote 180 plus 16.6. And from this point, this is 360, we can come back to this point so that we come to this point, which is same value. So 360 minus 16 will give us the second answer. So these two values will be the values that are in the provided range. Why we are calculating these? Because we are given that we need to write the answer between x between 0 to 360 degrees. So that's why we are writing this. So the first answer will be 196.6 to one decimal place. And the second answer will be 360 minus 16.6, 343.4. Okay, question 23, simplify this. Okay, so we have to see how we can simplify this. Analyzing carefully, we see that 2 is common in the denominator, and we try to take common from, because there are 4 terms here, so we can make pairs. From first pair, we have 3y common. 3y is common from the first pair, so we get x plus 12. So 3y times x, 3y xy, and 3y times 12 is 36y. And from these two, negative 5 is common. So x plus 12. So negative 5 times x, negative 5x, negative 5x times positive 12 is negative 60. Similarly, in the denominator, we have 2 common, the x squared minus 144. Then in the numerator, now we see that x plus 12 is common. The bracket is common, so we can pick it out. So we have 3y minus 5 over 2. And what we see here is x squared minus 144. 144 is square of 12. And when we can write two numbers with squares like a squared minus b squared, so we know that it can be factorized. It will be a minus b, a plus b. So it means this is x squared minus 12 squared. So we can write this as x minus 12, x plus 12. And now we see that x plus 12 are common. So our final answer will be 3y minus 5 over 2 into x minus 12. Okay, that's it for this paper. Thank you. See you again with another paper later. Till then, bye.